in the lab this week, what we're going to do is we're going to determine the enthalpy of vaporization for a specific compound, in this case ethanol and methanol. And we're going to do that by looking at the vapor pressure of those two compounds. Okay, so if we're going to look at the enthalpy of vaporization, that would be where we have methanol liquid go to methanol as a gas. The enthalpy for this process, this is a vaporization process, right? You go from a liquid to a gas, would be our enthalpy of vaporization. So we're forming a vapor, okay? Our goal is to figure out what that value is, okay? And we're gonna do that not by looking at how much energy we have to add to make something evaporate. We're gonna look at it and see how this information relates to its vapor pressure. So let's talk a little bit about vapor pressure, okay? So let's say we have a flask, like you guys are going to be given in lab, and into that flask we have just air, okay? Well, what we can do is we can then go ahead and add a few drops of maybe methanol or ethanol, and then we'll go ahead and we'll cap that off, okay? When we cap that off, what we would notice is that eventually, right, we have our methanol in here, we would get gaseous particles of methanol filling that container. Well, we're not above the boiling point, of methanol. So why do we have gas in there? Well, every substance that's a liquid exhibits a vapor pressure. So it's interchange between this liquid and the gas above it. That's what we're going to measure. And so what we'll do is we'll go ahead and we will take a thermometer because we want to measure the temperature, and then we will also have in here something that we can go ahead and measure the pressure, okay, because we're going to need those two pieces together. Now, thinking about this pressure that we're measuring inside of here, well, the pressure that we're actually measuring is a total pressure, right? We can't differentiate between our vapor pressure and the pressure of the air that was originally in there. So we're going to see the total pressure is equal to the pressure that our air contributed plus the vapor pressure maybe of our methanol if we put that in there. So this piece is going to contain both of those two. Okay. This pressure here is the pressure of the air that was originally in there before we added in our methanol. Because if we cap it off, we've gone ahead and we've set that pressure that we're going to be dealing with. Well, now we have these two pieces, right? Well, we really just care about the vapor pressure of our methanol. Well, we're going to see how does that relate to our enthalpy of vaporization. What we'll see, this is called the Clausius-Clapeyron equation, that the natural log of our vapor pressure, okay, in this case if it's our methanol, is equal to the negative of the enthalpy change of vaporization divided by R times 1 over T plus a constant depending on what the compound is, okay? And so now we see if we measure various temperatures and various vapor pressures, we're going to get a correlation, a relationship between these two, right? Because this is a gas constant, right? 8.314 joules per mole Kelvin. Well, now if we have those, and the only other variables is going to be our temperature and vapor pressure, what we can do is we can go ahead, we can add some heat to this, and we'll see that our temperature will go up and our vapor pressure will go up. And then once we're able to get to a correlation between these two, we'll see that if we're going to be able to graph these linearly in some way, right? That's for you to determine in class. And that's going to tell us something about the enthalpy of our vaporization. We see that that's related to our vapor pressure and our temperature. So we're going to do this for ethanol, we're going to do this for methanol, and we're going to see that because they have different enthalpies of vaporization, they're going to have different characteristics of their vapor pressure versus temperature profiles that they're going to get. So I hope this gives you a good introduction to what we're going to do in lab this week. We're going to take a liquid, we're going to look at its vapor pressure, we're going to use that liquid's vapor pressure to go ahead and to calculate what the enthalpy of vaporization is for that specific liquid. We're going to look at ethanol, we're going to look at methanol.